good morning. So as Alexi said, I'm a professor in the School of Computer Science at Carnegie Mellon University, and I do research at the intersection of programming languages and distributed systems. And I actually would love to talk to you about a number of research projects that I'm doing, but it's also really, when I'm addressing a whole group of people, and everybody is very different and they have different backgrounds, it's talking about my research that maybe only 12 people in the room might be interested in is kind of like a waste of everybody's time. So I'd like to talk about something else that's really, I think, super important to all of us and that we should maybe try to pay attention to, especially in the coming couple of years. So as Alexi said, I'm an assistant professor at CMU. I sort of co-founded the Scala Center with Martin Oderski in 2016. I did my PhD with Martin on Scala. I did a bunch of things related to Scala, like, I worked on futures and the concurrency libraries, wrote a lot of documentation, worked on the Coursera MOOCs. I did a lot of stuff related to Scala, so I'm probably responsible for something you're pissed off at, and I'm sorry about that if I ever did do anything that annoyed you. And I joined CMU as an assistant professor in 2018, and the sort of things that I'm doing at CMU is trying to bring techniques from programming languages to distributed systems. And particularly, I'm working on about 3 projects right now. One is about making microservice architectures actually more reliable and convenient to use. So like you're using one programming language, even though the whole point is not to use one programming language. And we work a little bit on distributed actor runtimes. And I'm happy to talk about all of these things, but please talk to me about them offline if you're interested in any of these things. I would love to chat about them, but this isn't the topic of this talk. And I'm working at CMU with some great folks. You might know Chris Mickle-John and Zishan Lakhani, a student called Matthew Wiedner working on CRDTs. And if you're interested in a PhD, come talk to me. But sort of the gist of this talk is, in 2016, or 2015 actually, I was graduating with my PhD, and then I was like, okay, now I have to be the executive director of this thing that nobody even knows what it's going to be yet. So what do we make? What do we create? And really the most important thing at the time was like, okay, there are problems in the Scala community, not just with community governance, but also with how do we keep libraries alive, and how do we, keep people who are working on these things, how do we fund the most important parts of the ecosystem that everybody needs? So my focus at that time became, I was hacking around on programming languages-y, compiler-y things, and then suddenly I had to shift 200% to sort of open source Scala ecosystem, things like that. How do we improve the developer experience for everybody, and not just the people who are paying into the Scala Center, but anybody who has an internet connection? They deserve a good sort of developer experience, especially for Scala. If they want to learn our programming language, it should be not ridiculous and terrible for them to try and learn it. And so when I had to suddenly shift from a whole bunch of technical stuff to sort of looking at community and ecosystem, I was also going around talking to various companies a lot, and I learned a lot of things that I couldn't really articulate and share with other people because I didn't really have data points or anything to share with others. But it was a lot of things. It was not just health of open source ecosystems and how to sustain stuff that seemed to be a problem, but there was also problems with onboarding new people, all of these things. I mean, it wasn't just Scala only, right? It was everybody has these problems. So I noticed that this wasn't just a thing, because people from other programming languages communities would come and talk to me about it because, I'm good friends with the people who run Rust. And we share tips all the time about weird stuff that goes on. And we're like, you did this well, how do we learn from you? And then they come to us when we did something well, and they're like, well, how did you do that, right? So I found out that a lot of these things, that seemed to be my problem as the person in charge of the Scala Center were actually really most people's problems. And so that brings me to the topic of this talk. I started actually at that time in about 2015 collecting a whole bunch of data, just every time I would find something. And that sort of jived with some of the things that I was observing. And basically it's on these 3 topics that I think are important for all of us to just make a mental note of and walk away with. The first thing is that in the last 5 years, how we actually build software has changed. I know that a lot of people make these sweeping statements. I have data to back it up. The other thing, of course, being the Scala Center person, I'm like, oh yeah, stuff about open source is changing as well, and there's things that we all depend on that we should be sort of aware of things going on in that world. And then also what we think a software engineer is. When we want to hire a new software developer, actually, what most people in this room thinks a software developer is, you're all wrong. Because it turns out that there is this massive influx of people that have almost no experience coming in at like a rate of 10 times like the number of people that like, you know, are in this room when they came in, right? It's insane. And so I'm going to touch, basically what I'm going to do is I'm going to go through and provide data on these 3 areas, and then I'm going to kind of conclude with some observations that I've been able to derive from these things, and I think that they're important for all of us to walk away with. And the first thing, you know, okay, how people get into these jobs is changing. We all know that hiring is not easy. Like if you work on software, you know that it's hard, and everybody writes articles about it all the time. But actually I went and collected data from, so this is a graph that I made based on data from the Department of, the Educational Statistics. And so there's other data to superimpose on this that comes from the Bureau of Labor and Statistics. And again, this is, so I should point out, this is like, you know, US data. So like if you came from abroad, this maybe it does not match with what you see. But the point here is, so this is basically the number of computer science degrees that have been awarded every year. And the data, actually, this is the most recent data point because they have like a 3-year delay on publishing these things. And the point here is that if you look at all of the universities in the US that are graduating people with computer-related degrees, so like information technology degrees, computer science degrees, computer engineering degrees, we're graduating around 60,000 people per year in the US. And currently, the rate of growth is about 7.4% per year. So the blue is like the years that we actually have numbers for. The red is basically based on this projected growth rate of about 7.4% per year, what it should look like. And then, okay, well, you know, what about coding boot camps? Those things exist, right? I'll show you that in a second, but the Bureau of Labor and Statistics published this number in, I think, 2017. They say that there are 500,000 open computing-related jobs. So this could be application developer, this could be a system administrator. This is basically things that are broadly under the category of computing jobs. In the US right now, 500,000. And so, like, however I want to stack these things, you know, it's kind of hard to, like, you know, fill these jobs. These are the ones that are currently available, supposedly. And if I add into these numbers the people that are graduating from coding boot camps, because these would be also entry-level developers that we could potentially hire, this is what, you know, they've recently started publishing actually pretty good statistics about the number of people that are graduating from these things every year. And the growth rate is 14%, so I can stack them on top of our CS degrees, right? And then we can see that, you know, in 2026 we'll have about just under 200,000 people that could potentially in the U.S. be get an entry-level computing job is the idea, right? But the reason why I go to 2026 is because the Bureau of Labor and Statistics projects that by 2026 that 500,000 number is going to grow to 3.5 million. And that actually takes into consideration the people who are graduating every year. So this is kind of like an unfair graph, because if you've graduated, this takes into account the people who have gotten degrees and then gotten jobs. So we're still supposed to have some ridiculous deficit in a few years. And they say that only about 19% of these jobs are supposed to be able to be filled by people in the U.S. who graduated from American degree or universities. Assuming everything stays the same right now. So I mean, we can CMU is a fancy private school that's super selective. Like we could just say, hey, everybody, let's let everybody in and try to train more computing people, right? That's still not going to fix this problem. And I mean, it's not just some Bureau of Labor and Statistics numbers that I'm showing you, and everything is all about those numbers. You can actually see some of these trends in on the Stack Overflow surveys. So this is not exactly a perfect comparison to the slide before, because if you look at these numbers, they're all different buckets. But basically, what these things show is these are since 2017, 2018, 2019 Stack Overflow professional developer survey results. And the question that I'm showing you is the one where if you have a job, how many years have you been coding professionally? And basically, if you look at this one, 2017, you could say about 50% of people who answered that survey, and we're talking 40,000 people, have up to 5 years of experience. 57.5% of people have up to 5 years of experience in 2018, so that number increased. And so this is hard to compare with the other ones because, again, the buckets are a little different. But basically, people, 41% of people have less than 5 years of experience. But the whole point is that if you look at this, and these are, on the order of tens of thousands of people responding, a vast majority of all of the people responding to these things have only been developers for a couple of years. Everybody in this room, at least most of the people I've met, you're all practicing for more than 5 years. A lot of people in this room are. So the point here is that, we've got a lot of newcomers, and in particular, we got people with only 1 or 2 years of experience. And that number is expected to grow dramatically, and more dramatically, I think, than we can kind of comprehend. And yeah, we can publish some more tech articles about how it's hard to hire, but I don't know what we're going to do about this problem. So, a bottom line here is that the demand, at least if you want to believe all of the PhDs from random fancy places like Harvard in economics, talking about projections in the economy, if you want to believe those people, it looks like, the demand for developers is probably just going to get even more ridiculous than we can probably comprehend. And if you look at, even just the Stack Overflow surveys, the average years of experience of software engineers is going down overall every year. So what we really have is this tidal wave of newcomers entering our profession, and according to the government anyway, this is supposed to only just pick up speed. And we can't just do what we normally do. We can't onboard people the way we onboard people right now. If this is actually going to happen, and we're not going to fail at it. So one thing that's really nice is there's a guy who basically works on a coding boot camp in Tennessee. He makes this point that I think that we can all kind of agree with, which is basically, we've all had to write software in the last year, I hope. So this is not surprising to you, but it's meaningful to people who are newcomers, right? The point that he makes is that new frameworks are lowering the barrier to entry. He says that's a far cry from the days when you had to learn the syntax of several programming languages to build useful software. Rather than typing these 7 lines of code to get a menu to pop down, you just download the framework from a code base that allows you to do that in a simpler way. Frameworks are taking the hard work that developers prided themselves on out of the equation. So that's a good thing, right? So all of these frameworks, that we all make fun of all the time because every day there's a new framework, they're actually making it easier for new people to just do something useful and meaningful more quickly than, when we had to learn back some more years ago. And another thing that's happening, so I have these slides. These slides are currently posted, so all of these data points you can actually go and look at if you don't believe me. There are a number of there's a movement of other articles basically claiming that existing developers are burning out. I know a lot of people who have burnt out and actually changed professions. And I think that you all probably know 1 or 2 people as well. So unable to fill tech vacancies, employers shuffle off additional duties to current employees, which leads to burnout and has a negative impact on local business development. Over 30% of respondents of a survey done by Indeed.com admit that the issue accelerates staff turnover. So basically people are quitting their jobs because there's shortages and people are putting more tasks on the few people that they have. Those people are burning out and leaving. With companies unable to fill positions, current employers are expected to fill the gaps. In many cases, this results in employee turnover. Over a third of respondents of this Indeed survey said the lack of timely hiring has caused burnout in existing employees and affected their businesses. Again, this is a thing where it's hard to have data to show this, but I think a lot of people, we all know somebody who burnt out because they had a bunch of responsibilities on them, right? And this is everywhere. It's not just your company is bad and you're burning people out. All of us have this problem. So obviously, I could make the point here that increased diversity would help, right? We know that the people who are making software aren't always a representational sort of sample of society, so we could probably try to increase the number of people who make software by increasing diversity. That would be good. Also immigration, if we actually, the US got less bad at this, we could probably fill some of these jobs. And then there's the whole point about remote workers, right? Maybe we should be a little bit more open to this because it's going to be really hard to get people to do these jobs. But, fine, I can say that we have a diversity problem, but what do we actually do? We actually have to do something about this, and there's nothing that, what, we're going to wait for the government to do something? No, the government doesn't do anything in a timely manner, right? So, we can all individually actually do something, and that is actually caring a little bit more about mentoring, because if we had this onslaught of new people coming in, all of you all are going to have to get much better at mentoring other humans in order to not lose those new humans that come into your teams. And do I know how to mentor people well? I'm not going to claim that I do. I'm just going to say that we should all get better at it. But yes, again, diversity, immigration, and basically embracing remote work. These are also other things that can be done at a larger scale that us as individuals can't necessarily control. But like, we should maybe all focus a little bit more on mentorship. And so I'm not going to talk about. So I've got a few slides on diversity. I'm not going to talk about it. I'm just going to leave the slides up here so that you can look at it if you want to later. But this is actually a real research study that has quantified and the difference of diverse teams, and found that basically if there is gender and tenure diversity, like in terms of people's experience levels, like they've been working longer, with these two things, you actually have people producing software that's better in less time. And this is a scientific study that you have to be able to claim statistical significance and all of that. It's not just hand waving. And they've also done a study on people disengaging from open source. So women disengage faster than men. And they also find that people actually, as much as we claim that we don't really care about gender, the first thing we see is gender and how active you are as a developer. Psychologically, this is what we do. So just be aware, this is all real, and there's some studies that you can look at. I'm not going to talk more about it. I'm just going to say, if you actually look into those studies, we have science that actually says that diversity and mentoring and people mentoring each other makes you build better software faster. Like actually, really, not just hand wavy. I'm a woman having opinions. This is serious. You should really pay attention. It's science. Don't shoot the messenger, okay? All right, so I have a few slides. So this is, so I made a point about we got all these new people coming in, we should care about mentoring, right? And also that, frameworks are kind of a thing that newcomers use. I've shown one or two of these. I've shown this slide before, basically, and this is one of the first pieces of data I started collecting. I've been following the things that a company now called Synopsys, used to be called Black Duck, and Tidelift have been publishing. And basically, they survey companies, and they've been doing this for a long time. And in 2010, 39% of 1,200 companies, or about 1,000 companies that they surveyed, said that the companies, that they ran on open source. So, 39% in 2010, that's not a lot. By 2015, about almost 80% of those people said, well, yeah, we run on open source. Everything that we do is based on open source software. So this is also, just somebody answering a survey. How correct is this really? I'll show you. We have more data. But the main point here is that this is up over 2x since 2010. So basically, in 5 years, you see everybody kind of, switching over to using open source stuff over proprietary things. I think this is all not a surprise. We all in this room use open source software. If you do anything in big data, it's all open source, right? So the point here is, since 2010, people started depending a lot more on open source. And there's a lot of reasons for this. The main reason in 2016 was that people thought the quality of solutions was better. And in 2015, people, 2/3 of companies said that they wouldn't even consider proprietary solutions. So that's also interesting. Everybody is sort of fixated on we're just going to use open source by 2015. So it sort of became the default choice then. In 2017, 60% of companies said that they've increased their usage, and the reason why, the main reason, is that they don't want vendor lock-in. But these are all surveys. So we actually now have some data that's been published about, sort of anonymized scanned code bases, right? So Synopsys scanned over 1,100 commercial code bases and found that 96% of those code bases contained open source components. And even more mind-blowing, or actually maybe not mind-blowing if you work in a big organization, an average of 257 open source components they found per application. It's an insane number. Do you have any clue what any of that stuff is, if there's any security vulnerabilities? That's also scary, for the record. Not my point, though. So 96% of companies used open source in 2018. In 2017, 36% of the code base that they scanned was open source components. So, I know I'm giving you just numbers, and it's kind of hard to remember these numbers, but try to make a timeline in your head. So 2017, 36% of the code bases that they scanned were open source components. In 2018, that number increased to 57%. This is crazy, right? So many applications now contain more open source code than proprietary code, is what they found, which is shocking. So Tidelift also goes and does these sorts of things. And they found something very similar. So this was in 2018. They did, basically they found that 70% of people's apps are essentially open source components. So they're most of people's apps, but not their job to support or take care of. 20% of the applications that they were looking at were actually the business logic that people wrote, and then 10% was commodity infrastructure. So things like Kubernetes and Docker and MongoDB, stuff like that. So that's absurd, right? Like, that's completely insane. Like, let's just, take this in for a second. 36% of code bases were was open source components in 2017, according to Synopsys, and by 2018 that number became 57%. And Tidelift said that that number was actually 70%. So these two come in the same year. I don't care, like, fine. We're off by 10 or 20%, whatever. That's still insane. That's like a majority, right? So it's pretty shocking to think about, especially given, like, we all know that there's open source sustainability problems, but, like, holy crap. That much of our apps are actually things that we really can't say very much about. So these 2 points I'm going to make really quickly. The bottom line here is that this has been something that is not new. We all know this is not new. For a long time, especially startup founders have been encouraging other people to just rebuild or sort of build things out of open source components and not to invest effort re-implementing things or paying for proprietary solutions. And so this is the co-founder of Instagram in 2011, basically saying, borrow instead of building whenever possible, that you can get all of your infrastructure essentially for free. We all essentially do that now, right? And Nadia Eghbal in 2000, I think this was 2015, she made the observation that, or I think that was the year that Instagram was acquired, or maybe it was the year before that, I don't know, but at the time that Instagram was acquired, she observed that probably about $143 million of their $1 billion acquisition was probably due to open source, which is, also kind of like an interesting number, right? Like, things that they reused is worth about $143 million. And yet, at least according to Tidelift, these are numbers that they published for their 2018 professional open source survey. 62% of respondents say that they are required to financially support their open source work with their own funds, or that they receive no external funding at all. So this is actually, I think, a good graph, because it shows that a lot of the open source stuff that we work on, or that we use nowadays, at least half of it, or almost half of it, is supported by somebody. Like, usually corporate subsidy. An employer is basically paying for somebody to work on an open source component that other companies are using. This is, like, I think, the only way forward. Also people who do, these donations and whatnot, like, it's been shown that donations don't really work because they're, random amounts of money over periods of time. That's not enough to sustain a human on. So this is actually an encouraging number, although 62% is also still scary. That, like, if I look at 70% of people's applications being open source components, and I know that of that 70%, 62% is some random people doing this, on their weekends, that's a little scary. And I'm just going to make the point without going into it, into too much detail, but just make the point, that of course, there are things that are unsupported that we don't realize. We all remember in 2014, 2/3 of all websites at that time were using OpenSSL, and the Heartbleed bug was discovered in that year. And what was happening sort of on the person level is really interesting. So there was 2 guys, both named Steve or Steven. Steve Marcus noticed that, he was a contributor to OpenSSL. He noticed that Stephen Henson was working full-time on OpenSSL, and Marcus was just, volunteering around his job, right? So Marcus was like, well, hey, Stephen Henson, what do you do for a living? And basically, as a so Marcus was a government contractor, which, usually they don't make tons of money, and he found out that at that time, Stephen Henson was only making about 1/5 of what Stephen Marcus was making, which is very little. And Marcus at the time also considered himself to be a strong programmer, but he thought that, Stephen Henson was really like a god amongst programmers. And he'd been working on OpenSSL since 1998, which is like, if he's making this meager wage since then, that's pretty insane. He writes, I'd always assumed, as had the rest of the world, that the OpenSSL team was large, active, and well-resourced. In reality, OpenSSL wasn't even able to support one person's work because Stephen Henson was doing contracting work around the side. And we all know in retrospect, we didn't know about any of this until it happened, right? So there's a bunch of projects out there that we don't know that these sorts of problems exist. And I've shown this before. I think it's interesting. So this is a research group has basically worked out the truck factor of many popular open source projects on GitHub. The main point here is that of the top 133 most active projects, most of them have a truck factor of 1 or 2, which means if 1 or 2 people that were working on the project disappeared, then the project would essentially die because nobody could take it over. And just to zoom in and show you some of the names, this was a few years ago. This is probably 2015 that these numbers came out, so maybe this is all changed by now, but it's just interesting to note that a lot of these things don't have super high truck factors. Back in 2014 or 15, I guess. And so, that brings me to the community point, right? Like, how do you increase truck factors? Well, you should probably not fail at community and ecosystem then, right? Because you need more people to work on this open source project with you. And there's research results that point to that. So in 2013, this is actually the best paper at UPSLA, which is like the basically practical programming languages conference. And they basically found, after doing a bunch of, tracking 10 years of open source repository data and doing surveys on developers, they found that they were trying to answer this question about what parts of the programming language influence developer decision making, and the most important thing is there being open source libraries to use, and that people can easily extend existing code, which means that there are people who know the programming language already, right? And so what they observed, they saw that these are all extrinsic factors, not actually like features of the programming language. These are all things about the community. So they basically found that developers value open source libraries as the dominant factor in choosing programming languages. Social factors not tied to intrinsic language features, such as existing personal or team experience, also rate highly. So like this community factor turned out to be the most important thing for people adopting at least new programming languages. Is probably also true for frameworks. So, the point here is that, you could really argue that the success of some open source project is actually largely attributed to its community and the people who sort of rally around it. This is arguably one of the most important things, because these people are fixing it, these people are building new things on top of it, these people are answering questions. It doesn't matter how good the thing is if these people aren't there to make it better. Tidelift also has data on this, basically. And the data says here that, when they asked all of these people in 2018 what was most important, the most important things were ultimately extrinsic factors, right, related to community. So reliability and maintenance, the fact that people were regularly maintaining it, was the most important. And then the next most important, which is almost the same at the same level, was an active community. So basically, having an active community that was using it and supporting it was one of the most important things for people making decisions to adopt software. And so, if you look at all of the other factors that they asked questions about, respondents rated an active community as being over 20% more important than just the popularity of a project. So that's hugely important, right? So, and this is not just touchy-feely stuff. This is not just like, oh yeah, we should love each other. This is, like life or death of the things that you use and make up large parts of your code base. Is that we have to be good at this. So to stay alive, there should be a relentless focus on growing the community and the ecosystem, and that's not easy, and not a lot of people know how to do that. So, again, this is not like let's give everybody hugs, but community and ecosystems are actually one of the most important things to an open source project staying alive. So let's try to wrap all of these things up, because I gave you a whole bunch of data points, and now you're probably like, oh my god, this was too much. So I had these 3 areas that I was talking about, right? So on the one, how we build software, at least it appears, and what people say, and what these surveys that have scanned thousands of code base, these apps that have scanned thousands of code base tell us, is that at least now, more than even 5 years ago, 3 years ago, we largely glued together a lot of open source components instead of implementing them from scratch. This is just what we do now. And of course, there remain a lot of sustainability issues that we should at least be more cognizant of. Obviously, I have strong opinions about how we can try to correct these things. Please talk to me about it. But the first 2 are kind of related, right? Because if this one doesn't get better, we have less nice frameworks that we can glue together to build apps with, right? And on top of that, our idea of software developers is rapidly changing, just given to this massive uptake or increase in the number of people that are doing these jobs now. So most people are extreme newcomers, and if you have a few years of experience, you have no idea how many people are out there and are completely new to this field. And we have to, in the next couple of years, somehow uptake those people. And I mean, I don't care how good you are at some weird concurrency thing. Like, if you don't get better at mentoring, this is going to be bad for all of us. So, some of the takeaways, like what do we actually do? So as you can see, I'm just going to keep on repeating the phrase, we're getting a lot of newcomers, and I'm going to wave my hands again about that. And also that, those newcomers don't necessarily all have fancy computer science degrees. And maybe they don't actually need one because, the jobs nowadays are often gluing together frameworks. Frameworks are now king. I mean, at least if you believe the numbers that these other companies are publishing, people are gluing together open source components. And 20% of the applications that people are building now are actually software that you have to write, and the other 80% is reused stuff, right? So maybe you don't need a fancy CS degree. Maybe that's fine. Maybe we should be okay with that. And as a professor, I should probably not say that. But whatever. Another cool thing, how we've, at least in academia land, people have been saying since the 80s or the 70s that we should try to be good at reusing software. And I think that if there's a good thing to be said here, we're now really good at it. We really actually reuse things a lot. But the things that we're reusing are all largely open source components. Corporate subsidies are helping about half of these open source projects that we're gluing pieces together of. I mean, again, given these statistics. 60% is not funded, right? And people are funding it themselves. That's important. We should be aware of this. We don't want more Heartbleed situations, right? And again, I'm just going to point out that we're getting a lot of newcomers. So these things are all related. Like I said, this is all the same problem. I just don't know how to say it more succinctly. Basically, newcomers depend on new open source projects, and they depend on it being easy to use, and that's how we update, or that's how we bring people into our field. And applications are becoming majority open source, which is cool, I guess, right? But we continue to struggle with sustainability in open source, and we have to somehow address this. So if there's something that you should walk away with other than just being oh, Heather gave me a bunch of alarming statistics, I have a few points that I think are important for different groups of people. I presume there's no educators in the room, 3, and everybody else is either an engineer or a manager. For managers, I think that it's important that we all start embracing the need to be better mentors, and to actually put a greater focus or emphasis on mentorship sooner than later. And also, it's really important that we figure out how to give back to the open source software that we depend on. And practicing engineers, I'm just going to repeat it again. You should actually try to get good at mentorship. I have a resource out there that's kind of nice that people can look at if you'd like. I mean, I didn't write it, I found it, it's nice. And as educators, I mean, like I said, I'm probably one of the only people in this room that's currently doing CS education in a university setting, but maybe we should be cool with not everybody needing a CS degree all the time. And maybe we should try to instead figure out how to more quickly and affordably help people get the skills they need as fast as they can so that they can just become an application developer and fill these needs that we have in our society. And again, we should not forget to actually give back to open source and invest in the stuff that we build on. It's not enough to just throw money at a project. I had all these community slides. The whole point is that we actually need to invest time and energy in its community. And this is I'm just gonna let you, there's a link here and the slides are posted, but this is a really good good resource on mentoring, which actually just came out a few weeks ago, which is really nice. And at that point, I'm happy to answer questions, but I think I can do it when we're changing tracks. The slides are posted here. And I'm going to give them as well to Alexi and co. So in case you want any of these statistics, you can just look at the slides. And with that, thanks for listening. And if you want to come talk to me, come on up.